Hello and welcome back to this random to fix stuff. Today we have a giant box. I'll show you what this is in a minute. We'll just go over the outside first. It's a wooden box. It's got some wrapped in, I'm not sure if this is real leather or fake. I think it's fake leather. You can see kind of the outside coming off and the cloth base underneath it. It's got a little bit of padding in the front. There's a handle on the top. It's not particularly light. I'd say probably at least 35 to 40 pounds. Back, same deal. You can see here the cloth is torn and the padding is starting to come out. One underneath looks pretty clean though. I'll open it up so you can see what it is. Two options on the top and then the front. It's supposed to unlatch on the bottom. Just kind of stuff. There we go. This is an RCA P31, which is a portable radio from 1931 or 32. Portable in the sense that you can actually physically pick it up and carry it if you're strong enough. This is quite heavy, 35 to 40 pounds. Battery powered, uses all, I think it's, well, we can get into the details later. So it's got the one in front, it's got one speaker here. This is just a dummy. See, it's cardboard behind that. Antenna connections on the front, on-off, tuning, and volume. It seems pretty stiff. It's supposed to have 4 of these brass knobs. We only have one holding it in. These things are only held on by one nail. I think the latches on the bottom are, that one's loose, so it looks like there's supposed to be a line of screws across the bottom too. Those seem to be missing. So, not the best shape, but these don't seem to be particularly common. I mean, this is the first one I've seen come up for sale that I've ever seen. So, we're gonna pick this up and make an interesting project. I do like the portable stuff because I think that the portable stuff really shows the limits of the technology of the time. You know, if you're building a console, you don't really care how big or heavy it is. When you're building something portable, it really shows, you know, how much they could pack into this package, how small they could make it, how portable they could make it. And in this case, they couldn't make it that portable. But anyway, I think it's interesting to take a look at. So let's dig into this thing. It's pretty dusty. You can see all the dust on the front there. We'll take off the one remaining screw, which looks like it is already punched through the outer veneer. So I might have to see if we can do something about that. Take that off, and then this should just slide out, I think. Not the best, but slide out here. Slide somewhere. Don't have anywhere to put it. And let's see, how can we lay this down? I guess we can just lay it down. I'll lay it on the front. Let's see if it'll stand up this way. That kind of works. You can get a look at the back here. So, see, here's our chassis here. This is steel, I'm sure. It's probably at least 1/8 inch, I guess. I can measure that. Double check, but it looks like 1/8 inch thick steel plate for that. Yeah, I'd say that's not 1/8 inch. What am I talking about? Yeah, 16th inch. Looks about right. So it's definitely, you know, super heavy compared to the lighter stuff they used in later radios. So yeah, 16th inch steel plate for the chassis. It's definitely heavy. The tuning capacitor looks even thicker. Plated steel. So let's take a look at what we've got here. So you can see one tube is already broken. The rest look okay. See, there was some in the front there, and then more in the back, so I have to replace that tube. It's kind of a shame because it looks like all of these are globe style, including this one was a globe style too. This is 232. Might even be original tubes because 232 is the that numbering style fell out of favor. I think in like 32 or 33. So pretty shortly after this was made, they stopped calling them 232s and just called them Type 32s. So let's take a look at the bottom here. So you've got this is probably the oscillator coil, IF cans, copper. These copper dishes you can screw off the bottom to get a look at the internal coils. Same thing as what's in the radial 80. You got this resistor board here. Is that even held in? Must be. It feels pretty stable. So the resistor board there, these little microcapacitors, some little transformer here might be, I'm not sure what that is actually, because audio output looks like it's up here. I'm not sure what that little transformer is for. You can see the big, huge permanent magnet that they used in here. This was made during the time when most radios still had a field coil for the speaker. So their magnet science is how you'd put it, was not as great at this time, which is why a lot of radios used the field coil to get the high magnetic field. So when you didn't have the option for a field coil like in a battery-powered radio like this, they have to use these ginormous magnets here. They're probably not even that magnetic. Give a screwdriver here. Yeah. Somewhat magnetic here, but not super magnetic at all. You know, the little tiny neodymium magnets or whatever they use now in the speakers are much more magnetic than that. So anyway, you can see there is a little bit of rust here on the tuning capacitor. It looks like it's, oh, there's some down there too. I don't think the batteries would have been on top. It's the back of the can. I think the batteries would have gone down here, so how rust ended up on top of there, I'm not sure. Unless, you know, how they do with the vapors from the batteries or something, which I don't think these would have given off because they're all sealed batteries. But anyway, I don't think that's a big deal. It just looks like a little bit of surface rust, so I don't think I'll hurt anything. See, in the back we've got the tube chart and then the license thing. Some pieces of that broken tube. We've got a screw. Not sure what for. I did try it. It's not one of the ones that goes in the holes here. I think we're missing some pieces down here. I think there should be, you can see something is missing here. That could have just been, you know, a board to hold the batteries in place, but I don't see any place down here for those screws to go in for the bolts on the front, so it doesn't even look like there's a space for them either. See, up on the top here, you've got these blocks here with brass inserts for those for these things to go in, so these things screw in to there. But I don't see any on the bottom here, even though there were holes in the front of the cabinets, so that's interesting. Take a look at that. Looks like there used to be something screwed on the back here. I see screws, but nothing attached to them, so that's interesting. Okay, so we got a little bit of an overview here. Nothing major seems missing. I have to figure out where these wires go for the batteries. One of them is going to be, there should be 4, I would think. I think there's supposed to be 4. There's supposed to be A-, A+, B-, and B+. I don't think any of those are joined together, but I'm not 100% sure. I'll have to check the schematic. You can see this is the back side of the power switch, so it switches off both the A and the B. See, that'd be on, probably that's off. Yeah, nothing's touching there, so on and off switches the positive side of both the A and the B supply. So it cuts off the filament power and it cuts off the B+ when you turn it off. The speaker doesn't seem to have any holes in it that I can tell, so that's a good sign. So I think the first thing I want to do here before I proceed any further is do some continuity checks on all of the coils, because when I worked on my radial 80, when I got that, 2 of the IF coils were open. So I want to do some checks on that and see if I can guarantee that all the coils are going to work, and then we can go from there. Actually, this rubber thing is still squishy. They're both squishy. That's very surprising. Usually these are hard as a rock, but they actually feel somewhat squishy. How about this one? Yeah, it's squishy too. Right, so that's surprising. They don't look like they have squished somewhat though. They're not making solid. Yeah, you can see they're not making solid contact with the speaker, but they are somewhat rubbery. Anyway, that was a distraction. Okay, so let's see if we can turn this sideways. Get a better look here. Probably actually lay this on its back because these inserts in between, assuming these inserts in between the tubes are strong enough, I should just be able to lay this down, I think. Although it's going to be hard to get light in the bottom, so let me play on this to see what the best setup's going to be for us to work on this. Okay, so I got the bendy pad out here. I got the 1931-32, the title there, RCA service manual. So that's a nice section for this particular radio. So here it's got the overlay, and you can see it's supposed to have 2 A batteries and then 4 B batteries. Got some descriptions here. We've got a wiring diagram. It has the connections of the transformer, the capacitor pack, everything on the resistor board, and okay, so in terms of coupling reactor, okay, so that's what that thing is. That little guy on the bottom there is the coupling reactor, according to this. No idea what it does. See the internal diagram there of the IF transformers as well. So we've got different colors here. So green and is that blue come out of that one, and then green and blue come out of both of them. Okay, so I'll have to check the diagram. Looks like there's 4 wires that come out. Okay, so green and yellow on that one, and then green and yellow on that one, and so they're probably going to be the same wire colors. Can you see what I'm pointing out here? So there's a continuity between green and yellow, and between looks like blue and red possibly. Sometimes I have the colors so far away from where the wires actually come out. It's hard to see what color points to what wire, but anyway, kind of a rat's nest here, but could have drawn that a little bit clearer because I don't think they have the colors on the actual schematic. So here's the actual schematic. So there are 2 IF transformers here. I wonder if that's this must be that coupling reactor thing. So, never seen something quite like that before. Usually they just either they have a transformer or they capacitively couple the so this is the detector to the first audio. So usually they either that's interesting. Never seen this. Like it has a coil that goes into the center tap on this coil, which then has a capacitor over to the volume control, which then goes to the grid. It's different. And then down here we've got a push-pull 230s for the output. So this is a regular transformer, not a regular transformer, this is a push-pull center tap transformer for the push-pull, and then another transformer for the output. So, okay, so this must be the first push-pull, that's the second output push-pull, and that down there is the coupling reactor. So I'll have to check continuity through all those. You can see this is the antenna coil. So it's kind of interesting to me that this does not have a loop antenna in the box, because both of RCA's older style portables, actually all 3 of them, the AR812, the RCA 24, and I think the RCA 26, not RCA, Radiola 24 and Radiola 26, both had loop antennas built in, all 3 of them had loop antennas built into the box, This one does not. It has just antenna connections on the front for a long wire antenna. But I'm thinking part of the reason is because this one has an oscillator coil here, which is just, a small, not small by regular radio standards, but smaller than a loop antenna coil like this. That's one on the top of the chassis. And I think those older cell radios didn't have that coil. They just used the loop antenna as that coil. Again, not sure why they used the small coil here instead of the loop antenna, but that's pretty much all the early 30s RCA radios are like that. Late 20s too, I think. The radio 60 had the same design, just a small antenna coil on top of the chassis. So anyway, let's start by doing some continuity checks so that we see what we have here. So we're looking on these IF transformers, we're looking for yellow, green, and I think blue and red. So we'll set this off to the side, some will kind of fall off the table, and we'll start by doing that. So looking at this, I can clearly see red and yellow here. I think this is the green one coming out the back, so I think we wanted to check green and yellow, so we'll start by checking that. I can get on here. Luckily these wires under the chassis seem to have maintained their color. Oh, not off to a good start. Not sure if you can see my meter. Either that or I have the wrong wire. Maybe it's this one? Is that the same one we were just on? Well, the wires that go up to the back here, let's see where they go. So let me actually spend a few minutes to make sure I'm on the right wires first, and see if I can find the blue one, because I don't see that one at all. So the green wire actually goes to the plate of this tube, which is way back up in here. So if I go there and here to the yellow, at 88 ohms. Not sure if that is the correct resistance or not. Let me just check my thing here. I'm not sure if it'll say. It does not say. 88 ohms is probably fine though. That's probably fine. So the green and blue wire goes to the plate of this tube, which I can't even get my probe in there. That's gonna be fun. This stupid lip here won't fit past the coil, so somehow I have to probe something up in there. And then the red wire goes to this big glob of red wires over here. This is probably the main B plus terminal right here. So let me see if I can somehow poke something up in this area. I can't even see what I'm doing. I'll probably do that one off camera, but you get the idea. Okay, so I checked all of the coils in here, and so far everything seems pretty good. I checked some of the resistors too. Most of them actually seemed a little bit low on spec, which is kind of interesting. There could be stuff in parallel with them, but they seem pretty close, but just maybe 10% under or something like that. So usually these old dog-bone resistors drift way high, but these ones, most of them seem just like 10% under spec. Except for a couple 500Ks that are almost at 1 megohm, so I'll replace those. So the coils in here, there's the output transformer, the push-pull driver transformer, and then the coupling transformer, plus this big oscillator mixer coil here, and then the antenna coil on the top. And there's also over here, this guy is like a part of the coupling for the interstage transformers. So also the IF transformers too. So all of the coils had continuity. I'll show you some of the resistance readings here. So the IFs were right around high 80s on the one side, and then low 40s on the other side, 42 and 39. So all those look good. This coil here was 81. There's some weirdness going on. I'm not sure about L5. So L3, all these 4 coils are on this big one here. L3 was 54. L4 was 5.5. L5 has a tap in the middle, when I measured the entire end to end, it was 4.6. When I measured from one side to the tap, it was 1.8, and then from the tap to the other side, it was 0.1. So I'm not sure what's going on there, unless I have the wrong terminal for the tap, but the entire coil checked out at 4.6, so that's probably okay. I'm just not sure what's going on with the tap measurements. And then L6 was 1.2. So the reason for having this big, complicated overlapped coil is this radio was made before the advent of the mixer oscillator tube. So you have one tube for the mixer and a separate tube for the oscillator. And based on looking at the schematic, it looks to me like the mixing actually happens in this coil. So if we go down to the schematic, so you can see that this is L3, L4, L5, and L6. So all those 4 coils are all on that big drum coil. You can see this tube here is the oscillator, and then this tube here is the mixer. So it looks to me what happens is the oscillator, this is the oscillator coil and then the tickler coil here. So the oscillator is oscillating through these coils, and then the RF coupling is happening from the RF amplifier to the first, to the mixer on these 2 coils. But because all these 4 coils share the same core, I believe that's where the mixing actually happens, that the oscillator oscillating on the same core as the coupling here actually introduces the oscillator signal into that through the coil, instead of on a mixer oscillator tube where that mixing actually happens inside the tube. Just what it looks like to me. I'm not 100% sure, but it looks like to me that that's how they do the mixing on these older style radios. So this radio I think has 8 tubes, right? Didn't actually count. Let's see, 1, 2, 3, 4, 5, 6, yeah, 8 tubes. So that's without the rectifier. So if it had a rectifier, it would have 9 tubes, and this isn't a particularly high-end radio. I mean, for the time it's higher end, because it's super heterodyne, and some companies were still selling TRF sets at this time, but it's not like a super fancy, super high-end one. I mean, they didn't even use power tubes for the output, they're just the regular triode amplifiers. They did make battery-powered power amplifier tubes, but they didn't even use those here, they just used the regular 230 triode amplifier. So anyway, it's not a particularly high-end radio, but it still has 8 tubes in it, because this is before the advent of the multifunction tubes. So there is no mixer oscillator or like second detector mixed with the first audio. So like this is the detector, and then they have a separate tube for the first audio. In later radios, they'd have both those functions and the AVC all in one tube. Same thing with the mixer oscillator. They have a mixer and they have an oscillator. Later radios, they'd have the mixer oscillator all in one tube. And they also have an RF amp, which they omitted in later versions. I think that's because they could get higher gain out of their IF and audio on later radios. One thing I did want to check is see what the IF frequency is. Didn't notice that here yet. Yeah, see, 175 kilohertz. So this is a much lower IF than later radios. Later radios would use around 455, 460 kilohertz for the IF. All of these older ones use 175 around there. I think the Radiola 80 was like 180, the Radiola 60 was 175, this one's 175. So a much lower IF frequency, and I could be wrong with this, but I think when they switched to the 455 IF, that brought the gain of the IF stage up somewhat. So I think that's why they could emit like the RF amp in later versions, but just an educated guess on my part. I'm not 100% sure on that. So anyway, back to the coils. These are the resistances that I got measuring the output transformer. I got 615 ohms on the primary, and then 2.3 kilo ohms on this little extra winding here. Not quite sure what that one's for. It's just a winding with a capacitor across it. So maybe that's some sort of trap to cut out whatever they were trying to cut out. Not quite sure about that. And then 0.6 for this whole voice coil loop. That's always going to be pretty low. Probably that resistance actually is the transformer winding. Probably the voice coil is about 2 or 3 ohms. in parallel with, you know, a 0.6 or 0.7 or maybe 1 ohm winding here, and then that'll give you the 0.6. There's a calculation. I'm not going to do that in my head right now, but probably the dominant low resistance is the transformer winding. So anyway, I got 42 ohms on the primary of the antenna coil and 6.1 ohms on the secondary. Again, I have nothing to compare these numbers to, so I'm not sure if these are right. They're just what I measured. They should be right. Usually these coils don't short, I don't really think. I mean, there's no visible damage on them that I could see. So usually what I've found is they just go open or they work, generally. So since none of these are open, hopefully they'll all work. So I'm pretty confident with the state of the coils that they should be fine, so we can proceed with this, fixing this radio up. Have to recap, all of the capacitors live inside a big capacitor block, which is on the other side of the chassis. Let's go around the other side here so you can see this block here is where all the capacitors live. All the paper capacitors, that is, the mica ones, are separate, scattered around, but all the paper capacitors live in here, so we'll have to replace those. Obviously replace this tube which is broken, and then build the batteries. You'll have to make 180 volts for the B battery, and then just 3 volts for the A battery. So we'll have to get those built, and once we get the capacitors replaced, or I might even try it without replacing the capacitors, because I think these box sealed in capacitors are usually pretty stable. So I'll probably build the battery pack and try it without replacing the capacitors, and just see what we get. So I think that's going to be about it for this video. I have to get the batteries and build them, so that'll probably be in the next video. What we can do though, is take a look at this broken tube to see the internal structure. It's unfortunate that it's one of the globe tubes that broke, but I'm sure that the tube I replaced this with will not be a globe tube, because even if you can find them, they're very expensive usually. So take a look at the structure here. You can see this is just a shield. Alright, let's see what this is connected to. Looks like it's connected to the grid actually, which is kind of interesting. See, the grid is in there. So this is just a shield on the outside, and then behind that is a solid piece, and that's the anode. And then inside there is the grid. You can kind of see the strands of wires going across that way. Those are the grid wires. And then inside that, which even, yeah, you can just barely make it out in there. If I can show this maybe. Not sure if you can see it. There is a tent-shaped antenna, but not antenna, a tent-shaped filament. You can see it in the top. Not sure if you can see it. It's just barely visible. It's a super fine wire. These are battery tubes, and they draw very, very little current. Let me just bend this out of the way. It's not going to show, I don't think. In the center of there is a little hook that holds the antenna up. It's not going to focus on that. And looking in the side here, I can just barely make it out. It's a super fine wire. I don't think the camera's going to pick it up. Yeah, it's not picking it up. So 232, I think is actually a tetrode. I could be wrong about that. So there should be yeah, I can see it in here. There is a second grid. So the first grid that you see, okay, what's broken? Let me try from this side. Trying to get a good view in here. So I'm not sure if you can see it, but so you can see the outside here is just a shield, and then there's the solid anode cup, and then inside that is the secondary grid. and then inside that is the actual control grid, and then inside that is the very fine filament wire. And I don't think the camera is helping me out here, but there are actually two grids concentric. So the grid you can see is it's not the suppressor grid, I don't think. That's the grid in the third grid in the pentose is called a suppressor grid, I think. I can't remember the name of this grid off the top of my head right now, but it does start with an S, I do believe. Anyway, and then the grid inside that one is the control grid, which is what the signal goes on. This outer grid is just for, I think it's for secondary emission, cuts down on that. Trying to remember what exactly that is, but I'm pretty sure that's what it's for. So the control grid is what actually controls the flow of electrons between the filament and the anode. But my understanding is that sometimes when the electrons hit the anode, they can bounce back off the anode and be absorbed by the grid, I think is the issue. So they put the second grid in here for the tetrode, and that second grid is put at the same or about the same voltage as the plate, and that prevents the electrons from bouncing off the plate or the anode because of the same voltage, so it's not going to let them be attracted by the grid. That's my understanding anyway. And then for the pentode, they added another grid around that, which was kept at ground. So anyway, I know it's kind of a crappy view here, but just to look inside these globe tubes, you can see at the top, the only stabilization that they have for the elements is just this little glass drum here. Basically holds everything together, and then there's a plate. This is a microplate probably in the top here that holds it together. So that's why the glass tubes are more prone to microphonics than the ST-type tubes, and that's actually why they went to the ST-type tubes, because in these, you can even see in the complete ones here, there's no support from the internal tube elements to the outside of the tube. So you've got this entire assembly standing on these skinny little sticks in here, and any sort of vibration, there's not much stabilization against vibration of these elements because they're just standing on these little sticks with no rigid support. So that's why a lot of the older radios have these fancy, rubber mounts for the chassis and the speaker and everything, because it's so easy for vibrations from the speaker to vibrate those tube elements, and then you get microphonics, so you're actually feeding back mechanically into your tube elements, and then you get a feedback loop and all kinds of nasty stuff. So that's why they went to the ST-type tubes, and the ST-type, which I don't, yeah, you have one here. You can see in the ST-type, then they can put a stabilizer in the top of the tube, so that rigidly fixes the elements in here and prevents them from vibrating like that. Anyway, I think that's going to be about it for now. I need to get some parts. I need to get this tube. I need to get a whole pile of batteries to build the batteries for this. And I think we can pick up with this when I actually have something to do. So if you enjoyed this video, and thank you for watching.